Yes.
Um. Oh yeah. Okay. So if for the last equation where we just have the x squared and 2n plus 2 and 2n plus 3. If I forgot to write my limit as n approaches infinity and then I said equals 0, then I get
that seems like the type of thing that yes, they would take off point. So yeah, you can kind of see I squeezed my green limit as n goes to fit in there because it's easy to forget.
I mean, would they care about that on multiple choice?
No, multiple choice they do not care. It's just that if you were showing your work on the free response, you don't want to do that. But they might be chill with it if you had forgotten this and wrote arrow in or arrow 0. They might be okay with it. They're just really particular about how you use the equals. All right. Then last one, what's this? Limit then goes to infinity. Okay, same thing. Then don't need to explain again. I'm wondering what x is can I plug in. So let me take limit then goes to infinity. Plug in an n plus 1. This one isn't even a fraction, so I don't even need to keep chain flip. It's just n plus 1 over the n 1. And this one should be quick, I believe, because these are easy to simplify. N plus 1 factorial over n factorial. Oh, nice. X to the third, or x minus 3 to the n plus 1 over to the n is just x plus 3 on top. So we're left with nothing on the bottom. And then, okay, we're left with nothing on the bottom. This x is staying put. This x bit right here that I'm circling is staying constant, and n is going to infinity. So you got huge number times constant. What will this look like? Yeah, a huge number. It'll diverge. It'll be infinity. Oh, because of the absolute value. Good job. Wait. Well, the result will always be infinity, but the inside of this could be infinity or negative. Yeah. Correct. And then, okay, so another question, infinity, when is that smaller than 1? Never, ever. So you can't plug anything into x to make this converge, except the percent. So technically, it could be, no, we got a limit of infinity, meaning the sum gets too big. Therefore, this will never converge except for one time. Good job. Yeah. If this was 3, then it'd just be 0 plus 0 plus 0 plus 0 plus 0 plus 0. So that would converge to 0. It's a silly sum, but it would work. So interval of convergence, I guess it's just 3. But that's a weird way to say it. So x equals 3 is the only term that you can plug in. I'm going to say only converges when x equals 3. And that means that the radius is 6. Okay. And then that's all the problems for this part of the section. But remember, we skipped problem 1. So go back to problem 1 with me.
Oh, yeah, it's like
and mine is funky, so let me give myself some space. All right, and it's just a multiple choice one. It says here the sum, this conditionally converges at x equals 1. So which of the following must be true? Conditionally convergent. What's up? Oh,
given this alternating. Right.
It has to be, yeah, it has to be alternating to be conditionally converging. And the other thing too is that the ratio test, I guess I didn't mention this before, but the ratio test says if it's strictly less than 1, like if the limit is strictly less than 1, then it converges absolutely because of the absolute value. Right. Okay, so the fact that this was conditionally convergent at x equals 1 tells you is like a big hint about what that x equals 1, where that lies. So here's some time to think.
It's not absolute. But it has to be. It's not absolute, right?
There's a hint if you're not making progress in your mind. It's a little number line. I think we have time, so you guys keep thinking. I'll call on you in a sec.
Oh.
Are you guys have an answer or no? D. Anyone else? Okay. Okay. All right. So the idea was that, well, okay, where are they getting? Well, what were you going to say on it? I missed a lot of that. You said,
Yeah.
okay, I just didn't hear it. But okay, the hint I was giving is that the center of this is at -4 because of x equals 4. Okay, and they told you that at 1 it conditionally converges. The fact that it conditionally converges and not absolutely converges tells you that 1 had to be an endpoint. So this distance was as far as you can get from -4. So you can go 5 on either side. Okay, and this conditionally converged. But if you go 5 to the other side, ooh, let me try again. Ooh. If you go 5 to the other side, and get to -9. That doesn't, I mean, the first example we did had one endpoint converge and the other endpoint diverge. So this -9, you can't really say anything about. It might converge or it might diverge. We don't know. So it's none of the -9 ones. Although they're there for a reason. They're there to trick you because, oh, if one endpoint converges, then maybe this one also should do the same. But no, we just saw examples where that's not true. So the -9 ones, you can't say anything for sure. They might diverge or might converge. We don't know. But these -2 ones are well within the radius. And so if it's within the radius, do you guys remember what I said about it? Yeah, it has to for sure converge, absolutely. So it should have been C, it could have been F. Nice, y'all.
Wait.
Yeah, very good. And this is, I bet you might see a problem like this on the AP test, or at least they're on a lot of the practice AP tests that we have access to. So C is the answer. Yeah, Chelsea.
How did you know that it was?
The fact that it says conditionally converges. Again, if it had been within the radius, if it had been not an endpoint and it kept going past, well, okay, here's the 3 options. If one had been outside of our interval of convergence, then it would have diverged. If it had been well within, like this -2, then it had to converge absolutely by what the ratio test said. And the fact that it's conditional, that means that it had to be an endpoint. But they might even ask this without the conditionally part, and you still get kind of the same question. Like, even if we don't know that -1, like, if this was the same exact question without the conditionally part, it just says converge that x equals 1, then you can still do the same process. Like, I know that if I go 5 in this direction, I'll converge. But does that mean I can go 5 in this direction and converge? Not necessarily, because what if 1 was an endpoint? That's the only thing that would change if they did say conditionally. What if it was an endpoint? Then I couldn't say anything about -9. That would also be an endpoint, but I could say something about -2. That's well within. So even without the conditionally, in fact, I think the times I've seen it on the practice safety test that I have access to, they've asked it like without the condition. But it's basically the same question. Yeah, yeah.
Maybe I'm just really missing something, but it's conditionally converges that x equals 1, but then you plug in, like you just have the whole parentheses when it. That's like when because when x equals 1, then you get 5, right? Like inside the parentheses. So
maybe this, the A over N must have something in it. It must have some rule where it has what is it? Where it has a 5 on the bottom that cancels the 5 that you would get right here. Like what happened last time, or in this example. Yeah, okay, this is a lot of work. But what happened in this example is here's the x minus 5 center bit, and here's what this is playing the role of the a sub n. And so when we plugged in the 9 or the 3, the 3 minus 5 became a 2, which canceled the 2 down here. So the 5 that you're talking about when you plug in 1 must be included in the a sub n so that these end up canceling and you get some sort of conditionally convergent series.
Okay.
But now that maybe that wasn't even your question. Maybe your question was, is there a typo in this? Because now I see what you're asking. Shouldn't this be x minus 4 to the n? And the answer is, I think, yes, it could. And good catch, and I didn't catch that before. But I think that's the question they wanted, because that's a power series.
It's a why.
I guess the APM could just be even accurate, I guess, but it's like any, like is APM like where A and is that just any equation?
Yeah, that's just any sort of sequence with ends.
I mean, I guess it could be accurate,
I guess so. But a power series should have like x plus x minus number to the n. Like just by definition, here's me going back in time. It should always be blah 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 to the end. So Keaton's kind of right. Yeah, I didn't catch that before. That should be to the end. Nice, y'all. Good job. All right, 38. We have 7 minutes. Like I said, I didn't want to start 10.8 because it's not worth doing 7 minutes of 10.8. We'll just do it when we get back from spring break. But I had pulled up the homework, or I can read. Let's do the homework. I think that'll be more worth your while. But Kian, I can explain the Lagrange bound to you better later, like during stakes if you show up, or
that's a big if. Actually, not. I have to stay.
That's a good guy. All right. So then let's do some of these problems. Maybe I haven't done these in 1 year. I did these last year, but I did not do them this year. So I don't know which one's the best one, which one's the least confusing, which one's the most confusing. But let's just do 1 or 2 of them as long as we have time, and hopefully you get a better grip for this. Can we just go in order, maybe? I think let's just go in order. I don't see any single one particularly that looks harder or easier. So do 77. I'm going to do it silent up on the board in case you're trying to like get reassurance, but see how far you can get without looking up. I'll do it in dark blue.
Well,
10.7 is what problem 77.
bless you.
The first one my work is on. Trying to check it, but if you have questions, I don't know if we have time for another one. We might as well ask questions on this. The blue was the ratio test.
Are you comparing it? Are you comparing it to the 1/n, or are you?
No, it's equal to that. I'll get there in a second. So
Yeah.
ratio test, you just get this limit. Again, you get n over n plus 1 times that's -3. And the x minus 3 is like the coefficient of this n stuff. Because as n goes to infinity, x is staying put. Like you're taking the limit with n, not with x. So again, this is like a constant. So this limit would be the absolute value x minus 3. You want to know when that's less than 1. So you set up this little like double-sided inequality. X minus 3 has to be between -1 and 1. Add the 3, you get 2 and 4. Like straight inequalities, x less than 2 and x less than 4. And so then you check the endpoints. You plug in 4, you get -1 to the n times 1 to the n, but 1 to the n is just 1. So you just get this series that I'm circling right now. Actually, the video, you can see what I'm circling. I'm circling it right now with my little mouse. And that converges. This looks like a harmonic series, but it's the alternating harmonic series, which does converge by the alternating series test. It is alternating. It decreases in magnitude and has a limit of 0, so it converges. That's the alternating series test. So the 4 we include, that's why there's this little line under the 4, but you plug in 2 and you get -1 to the n times -1 to the n over n. And these two end up combining. So like n plus n is 2n. That's me circling with 2n right here. That's always even, so you get a positive number out of that every time. And so you just get this straight up harmonic series which diverges. So 2 is not included in the. And the other ones will be similar, but like maybe more fancy. Like eventually you get factorials in there, you get 2 to the n plus 1, you get things 2x minus 3 instead of just x minus 1. But still, it's the same idea for all of them. Good job, y'all. All right, I gotta make some rows. My algebra one's about to take the test, but you guys did good.